Today, I will be discuss about biodiesel. Okay, biodiesel is a type of diesel fuel that is made from vegetable oil and animal oil rather than fossil fuel oil. Okay, the purpose of this experiment is to produce biodiesel from the used cooking oil through the process of trans-esterification. The experiment demonstrates how materials such as used cooking oil were made into biodiesel that is not only reduce waste management but also reduce environmental pollution. Okay, the purpose of this experiment is to explore the synthesis of biodiesel as its visible alternative to the fossil fuel. Okay, this study aim to evaluate the feasibility of producing biodiesel from existing raw material and understand the trans-esterification process and evaluate the physical and also the chemical properties of the resulting biodiesel.
In this experiment, we use vegetable oil, sodium hydroxide, methanol, hot plate mixer, beaker, scope bottle, thermometer, magnetometer, measurement, aluminium foil, and filters.
My name is NORZI SYAZWANI BINTI AZIZ. My metric number is J228082. Now I'm going to talk about result. For the result, we got three observation, which is before, during, and after. The result above shows the observation that have been made for the production of biodiesel from used cooking oil. There are several based on the observation before the experiment. The color shows brown resembling used oil, while the texture is still liquid and has a rancid smell, and no base condensation occurred at this time. In addition, during the experiment, the oil turned a deep reddish brown color. The texture of the oil is still liquid, produces bubble, and still has a rancid smell, and there is still no separation phase. Then, after the experiment was done, the results showed that color of the oil changed to yellow egg yolk, while the texture became thick and soft. The resulting odor was less rancid and there was no phase separation, thus the experiment was unsuccessful.
My name is AYUNI binti ROSLI and my metric number is J22A0129. So now I will explain you about the discussion part where I will explain the potential reasons why our results turned out to be like that. Firstly, our experiment was unsuccessful. This is because based on our observation on the color, the final bright yellow like egg yolk color indicates an incomplete reaction due to the slow heating, leaving the unreacted oil that affecting the outcome. Another observation that we get after the experiment is based on the texture. The used cooking oil started as a liquid and formed as a bubbles after combining with sodium hydroxide and methanol due to the stirring. However, the end result was a thick and soft texture. This was likely because of inconsistent heating. The third observation is on smell. We noticed that the original smell of used cooking oil had a strong rancid smell, but became less intense in the final experiment. This is because of the removal of the compounds that causing the rancid smell, but the final product still retained a mild rancid smell. And lastly is phase separation. There are no phase separation occur throughout the experiment, leading the experiment unsuccessful. The lack of separation between the biodiesel and glycerin due to the improper temperature control, as low temperature can inhibit the reaction and also prevent the separation.
This highlights the importance of the precise temperature regulation, accurate chemical measurement, and careful handling equipment despite the failure. The experiment provided valuable insights for improving future biodiesel production attempts. For the question part, the first question is which layer consists of biodiesel and how do you recognize it? So the answer is the biodiesel forms the top layer due to its lower density compared to glycerol, which settle at the bottom after the mixture rests for several hours. However, in this experiment, no phase separation occurred, indicating an incomplete transesterification process. Factors such as inconsistent temperatures control and inaccurate reactant measurement likely contributed to the failure and making it difficult to visually identify the biodiesel layer. So the next question is how to prove the consists of the biodiesel. To prove the presence of biodiesel, several methods can be used. The first one is the phase separation is approach, where after a successful transesterification process, the biodiesel forms the top layer due to its lower density, while the glycerol settles at the bottom. The biodiesel typically appears clearer with a yellowish tinge. Another method is the water test, in which a small amount of the water is added to the sample. Since biodiesel is insoluble in water, it remains separated, while glycerol and the methanol dissolve or mix with the water. Both methods can help visually identify the biodiesel from the other components. For the last question is what is the reaction and process involved between a mixture of methanol NaO and used in cooking in biodiesel? The answer is the transesterification process involves the reaction between the triglycerides in used cooking oil and methanol in sodium hydroxide NaO acting as catalyst. When NaO dissolves in methanol, it forms sodium methoxide, which break down the triglyceride into the methyl ester and glycerol. The reaction occurs between 50 to 60 degrees Celsius, after which the heavier glycerol settles at the bottom and the lighter biodiesel forms the top layer. Proper temperature and catalyst control are essential to ensure the complete reaction and phase separation.